Okay, so we're into 7-6. So what we're doing today is solving radical equations. So scenario 1 is you only have one radical sign. If that's the case, you're going to isolate it, which just means you get it alone. And then we're going to square, probably, as long as it's a square root, we're going to square. But if there's some other index other than 2, we're going to do that power. Like, this is a square root, so we're going to have to square. If I had a little 3 there, then we'd instead have to eventually cube it. If I went like this, you'd be really mad at me because we'd have to take it to the 10th power and you'd be sitting there like stuff times stuff times stuff times stuff for a good long while. But most of these are going to be square roots. So based on that description, what would you do first to solve this thing? We'd subtract the 4. We're doing our opposites. So the square root would sit there for a second. Instead of adding 4, you always do the opposite. So subtract 4 and we've got 6. So that's move 1. First thing we want to do is isolate that radical, get it all alone. We just did that. Now we're going to square. When you square the 6, it turns into 36. When you square this, it's even better. It's just 3x. When you square a root, those just cancel each other out. That's what the opposite is. So to undo a root, we square. Just erase the radical sign, copy down the radicand, other side changes. Answer would be 12. Always a good idea on equation day to check it. So if we put 12 in, 3 times 12 is 36, rooted,
6
plus 4,
10.
that works. That's a win. Question about that. So do a couple more like that. So this, there's a little bit more stuff going on. To get the root alone is a little bit more lifting. Well, what would you do first?
Add the 2.
Add the 2. So when we add the 2, that turns 10 into 12. Always do the adding or subtracting first. Then divide by 4. If you divide by 4, the root is then alone, and the 12 turns into 3. So that's phase 1 again. Isolate that root. Now it's time for us to square. Question about halfway point. Square the left is nice. It just makes
X plus
3. Make sure you remember to square the right. That's probably the most common mistake I remember grading over the years in this. This one just copies without the radical sign, and sometimes people get a little carried away with their copying and just put a 3. That isn't a 3 anymore. That is a 9. So final answer is 6. Question about that? I would check it. 6 and 3 makes 9 rooted, 3 times 4 minus 2. That all works. Something there. This one, be a little bit bigger. So what would you do first?
Subtract the 3.
Subtract the 3. If you subtract the 3, that's going to change 28 into 25. Then what? Divide by 5. So the root would be alone. If we divide this stuff by 5, x plus 5. Question about that? Halfway. Got it alone. So now it's time to square. Left side is easy.
Same.
X squared plus 65. This side, not so easy.
X squared plus 25.
I agree with all of that. Invisibly, what's on this side? Parentheses. There are parentheses there, and we're now squaring that. The full side has invisible parentheses. If we do x plus 5 squared, some of you feel more comfortable by writing twins side by side and foiling it. Others have just picked up on the pattern of how this goes by now. But we're going to get an x squared. Some of the audience did say 10x that comes from a pair of 5x's. Some of the audience did say plus 25 that came from the 5s. When we square this side, it needs to be a foiling problem that time. about that. So now what? I wouldn't factor yet. It's possible because of the x squareds and stuff. We might end up in a position
I
where
say
we
the
have
best
to
bet,
factor.
take the x squared out, just erase it.
Yeah, if we try to get like similar things to the same side, the x squareds, whichever way you zig them or zag them,
You know,
they're going to wipe each other out. This is adding, this one's adding, so if we try to do some subtracting, these x squareds are just going to eliminate. So then we're just chasing this x to get this one.
subtract the 25.
Subtract the 25
40.
is 40,
X equals 4.
we got a 4. I would always check these. Some of these are not going to work when we check them. But 4 squared, 16, add 65, 81 rooted, 9 times 5, 45, add 3, 48. We have to remember 48 for a second. If we go over here, 5 times 4, add this,
48.
we're good. Most of the time they'll work, but they won't always. We're going to uncover a problem eventually if we keep checking. Something there. This, I cut you a break. Why did I cut you a break on this one?
Don't have to get it alone.
We don't have to get it alone. We're already ready to
Square.
square. So left side,
X equals 5.
x plus 5. Right side,
X squared minus 1.
some people are saying 2 things, some people are saying 3. Should there be 2 things or 3? 3. Why 3? Because there are going to be 3 things.
Because there's x squared, x to the 1, and then just the other.
Yeah, because what's here invisibly again, second time around. This is like it's in parentheses, squared, which some of you are going to feel more comfortable writing twins when we square that. If there is an x squared, everybody I think yelled that.
Minus 2x.
Minus a 2x is something not everybody
Plus
yelled. Plus 1 is not a thing everybody yelled either. Question about how we got to that. Basically, when you get to the squaring phase, if the root is alone and there's just a number, just square the number, no fuss, no muss. But if the root's alone and there's some adding or subtracting going on, you're going to have to FOIL stuff out. It's going to be a bigger ordeal. Unlike this one, where the x squareds would vanish, you've got non-vanishing x squared, you've got x's, you've got numbers, you've got all this types of stuff. How have we solved these
Make
in our
it equal
history?
0.
Make it equal 0. If you have x squareds, x's, and numbers, you have to make the problem equal 0. X squared has no friends. X's have some friends if we get all the x's to that side.
3 plus.
Minus 3. How about the number total? Minus 4. We'd subtract the 5 out of there, so that would get us down into the negative. We'd subtract the x, that would get us further into the negative.
I did the 5. I thought it was 5, right?
Question about moving that?
Show me.
Okay, then what? What's up with that then?
Then you factor
Then we factor. So xx
plus minus
plus minus,
4, 1.
minus with 4 plus with the 1. This gives me
3. I mean
4 to 4. This gives me negative 1. This is a little more suspicious that it might not work because there's like 2 answers. So, I mean, let's check it and see what happens. If I put the 4 in, x plus, or 4 plus 5, 9, rooted,
3.
is 3, 4 minus 1, 3. That works. Negative 1 adds 5. 4. Rooted
2.
is 2. Put the negative 1 over here. It's negative 2. Is that okay? No. Why was it close to okay then? But that isn't really.
Because it's 2 versus negative.
Yeah, so if I said to you with words, what are the square roots of 4? You would say 2 and negative 2. And that's what we just did. We just did a square root of 4 and it turned up negative 2. Like math wants that to happen. But when this symbol gets used, what's the rule when that symbol gets used?
Only positive.
Positives only allowed. So even though like the math world out there wants that negative 2 to come out just like it wants the 2 to come out, this symbol, the rule is no, we can't do that. So sometimes when you plug answers in, you know, if I made this equal negative 10 or something, or somehow I made this be negative 6, like you might get a thing that's just not supposed to, not allowed to happen. It's kind of like, remember the one day we had word problems where we factor and we get like 7 and we get -9. We throw away the -9, but usually there was something in the story that would resurrect somehow a +9 because something was like 2 more. It just sort of felt like, I mean, math is not a personality, but it felt like math wanted that answer and it tried to come out. And we had to like shoot it down, but sometimes it found a way back. That's just how it felt. Question about that? Okay, let me do a quick what if. So let's say this was a 4, no, let me go back to one of the easier ones. Let's say this had a 4 index. This would have had a 4 index. When I got to this phase, this would still be that same copy. But what would I have had to do over here if there was,
Multiply that by 2.
we'd have to go 3 times 3 times 3 times 3. So if they sneak an index in there, you're not just going to square, you're going to have to like bust out your fingers and multiply a bunch of numbers or use a calculator or something. You'd have to go 3 times 3 times 3 times 3. Question about that? Okay, phase 2, before I make my way back to the problems that'll be on the left where there's a little more room. Sometimes there's not one radical, sometimes there's 2. So when we get over there, you'll see a bunch of problems that have 2 radicals in them. If you have 2 radicals, we take a difference of opinions. What we're going to do is get 1 radical on each side of the equals. We're going to square. We hope they both get eliminated, and that's possible. But sometimes there's still 1 radical left. If there's no radicals, we're happy. If there's still 1 radical left, we're going to have to repeat the process like what we've been doing the last 10 minutes. We want to get that one alone and we'd square it again. But it might be twice as much work if there's 2 radicals, which is probably not that surprising. Question about the idea, get 1 on each side, then we'll square. So strolling leftward. So this one, was I kind or unkind in the setup? Kind. Why was I kind? There's already 1 on each side. We want to get 1 radical on the left, 1 radical on the right, get 1 on each side, and that's readier to go. Kind or unkind? Unkind. Why?
They're on the same
They're on the same side. How about that one? Kind. Because they're on different sides. Okay, so we want 1 on each side when there's 2. So this, there's 1 on each side, let's just square. When you square this,
X plus 3.
that would be x plus 3. But you also have to square this.
4.
4. And what punctuation is there for the 3rd time today? There are parentheses that are there. What's up on that side?
X minus
X minus 2,
9.
as well as 9. That's what made that new. We've never done that before, we just did. Hooray for us. There was a root on each side, we squared, and now we should be good. This is more old-fashioned. Something about that. So go at it, what would you do? Distribute, so
4x squared.
4 is 12,
9x 18.
9x minus 18. I'm going to send my x's that way,
5.
5. Send all the numbers the other way,
30.
30, total
6.
6. And I would check it just to be sure. Question before we check? Add
9.
root 2
2.
times that,
6.
6. Over here,
4. 2. 6.
whatever. Something there. And this one. Leave one of the radicals where it sits. Take the other one out of the way. So something like that. We'll get 1 on each side. Question about that? Square the left. Agreed. Square the right, we're going to have all people yell all kind of different things. So let's first settle on how many items are we going to get? 3 is correct. Because for the 3rd time today, what's over here that I can't see but it's there? Parentheses. Anytime there's an adding or subtracting going on already, and there's 2 items over there, and now we're going to try to square, this has to like multiply its twin and make some stuff happen. So 7 times 7 is not bad, 49. The root times itself is not bad,
Just the root.
just x plus 12. Negative times itself would make that positive. But if we're foiling this out, 7 would multiply this root and be negative, and it would have a twin. There'd be 2 of those. So we'd have negative, not 7s, but 14 of this root. And that got messy. So we rewind something there of that messiness.
Yeah, so I was fine up until the 14. Why did it 14?
So if it makes you feel better, I'm gonna erase this because it'll hog the space that I need for that problem. But when we're squaring, there's twins of that factor. So this, when we FOIL it, would make negative 7 of that root. Then that pair makes another negative 7 of that root. So altogether, there's negative 14 of that root has survived on.
Yeah, I'm fine
You
with that.
with that? And then I'm gonna need that space, so I'll clear that back up. Anybody else want to run back on that? Then this would have been hopeless 20 minutes ago, but it's hopeful because that's what we spent the first 15 minutes of class doing. We've got one radical left. So when there's one radical, we want it to be 11. So we're going to try to operate to a point where this radical gets alone, but we have a lot of stuff to like clear out of there to make that happen. So somebody clear something out? X's. This is adding x, so I can subtract x. When I subtract x, it can eliminate that other x, so that's not bad. Which number should wait the longest out of the remaining numbers? 14. The minus 14 should sit for a bit, so let me write a step where it's still sitting and deal with all those other numbers.
You subtract the 12.
We would subtract the 12. We'd also
Subtract the 49.
subtract the 49. So positive 5, subtract 49, subtract 12 more. It's a big negative wad of mess.
Negative
56.
56 is correct. Question there? Okay, root completely alone by dividing is 4. Once the root's completely alone, we like to have to square.
16.
So 16,
X plus 12.
x plus 12. Hopeful final answer is 4. I would check it. 4 in here, then root. It's 3. 4 in there, root. 4, 3 and 4 does indeed make 7. That is a chance. Something about that? One more of the same difficulty level. This one shouldn't be better or worse. It should be about the same. I started you a little bit kinder because
Both on every side.
one on each side already. So left side, not bad.
3x plus 1.
3x plus 1. Right side, here's going to be always your big crisis. Some people are going to want to write down 2 things, and some people are going to write down 3 things. So there should be 3 things. Anytime there's adding or subtracting, it's again, like there's parentheses, we're squaring it, there's twins, we're going to have to think about the FOILing process. What's one thing you'll get?
1.
You will get a 1. What's another thing you'll get?
X plus 4.
An x plus 4. What's the messy thing you'd rather not get, but sorry, you're stuck?
2.
2.
2
Root x plus 4.
of those roots. Usually, when there's one root on each side, you usually have to FOIL, you usually get stuck with one root next to it. Question there? Okay, ultimately, we'd like for this root to be 11, but that might take us a little bit of stuff. Something to do. The ones could cancel. Yeah, this is adding 1, so we could subtract 1. This was adding 1, so we could subtract 1. Yeah, the ones could drop out of there.
X's would be 2x.
X's will be 2x. If we get this x out of there, subtracting, we'd be at a 2x.
Minus 4.
We would get a minus 4 when we get that out of there. Who would still be waiting? 2. Question about the progress of how we got there. And what's left to completely get the root of 11?
X minus 2.
X minus 2, we'll do a divide. and we'll pause there for a second. Did we lose anybody? So where are we now? What do we need to do? Square. Once the root's alone, we're gonna square. Where the root sits is always just wonderful.
X plus
Just
4.
x plus 4, radical sign is gone. Over here, I'm gonna again get different people yelling different amounts of stuff.
Three.
Should be 3 things. If there's adding or subtracting, when you hit the square moment, you're gonna have to do a foiling move.
X
squared.
4x.
4x plus 4. Something about that. There's x squareds, there's x's, there's numbers, there's all kind of stuff, and you have to get those to equal 0. Anytime there's x squareds and x's and numbers, we need it to equal 0. X squared is stuck. What would be your x count? Minus 5. Your number count? 0. Gone. After we get those equal 0, we've always then, since chapter 5 anyway, tried to factor. How can we factor this? Take an x out. X minus 5. This would tell us 0's in the running. This would tell us 5 is in the running. Last time we had 2 answers. One of them failed. So it's definitely worth a check if you have 2 answers. It's worth a check even if you have 1 answer. I don't have any on the board, but I believe there are 1 answer problems in the universe that the 1 answer can fail. Okay, if there's a 2 answer problem, it's probably twice as likely that one of those is going to fail. So we'll check them out. If you put 0 to this side would have a value of 1. Because you'd have just, that would eliminate square root of 1 is 1. What's this side? 3. So, no. What math was trying to impose on you is this 1 and this 2. If you could accept a negative from this symbol and accept a negative from that symbol, that would now be true. But you're not allowed to accept negatives from that symbol, but like math was trying to make that happen and it just doesn't go. Put 5 in here.
15, 16, 4,
Root it would be 4. Put the 5 in there.
20, or 9.
9 rooted. Add the 1. So that's a win. Do you think it's possible there could be something that has no answers? Yeah, it's possible. Likely? I don't know. I'll look at the homework and see, but that it's possible. Question about what's up with those? The homework where we live on this is a 319. 319, we're going to skip the 3's. It goes to 34. We'll stop a little bit short of where the finish line is. So 34 is your final stopping point. There are 2 that one that you'll do that has no answer. There were several in the homework with no answers, but there's one that you get to hit. The other ones were multiples of 3. But there's one that you'll hit that has no answer. There's also probably some that had 2 answers and 1 got thrown away, but I can't tell that because all I have to look at right now is the answers. But just check them, make sure they work, but there are definitely at least 1 that has just complete failure. Yeah. Yep. Anybody need anything about any of this?